welcome to Oscar and Philip or Philippe. I'm just gonna leave it straight to you to actually introduce yourselves. But we're gonna
just say Southern Hemisphere world-class bumblebee experts.
Thank you.
And other things that they'll tell us about.
Yeah, thank you very much, Sam and Claire, for the invitation. We are both really happy to be here. So we're gonna start with a small presentation. Well, I don't know if it's small, but a presentation. And afterwards, we're gonna do a little taxonomy run with Philippe. So yeah, I'm gonna start with the presentation and I'll let you guys know a little bit of ourselves. So please let me know if you're hearing me and if you're seeing the presentation.
We have you.
Great. So my name is Oscar Martínez López. I am actually from Guatemala, but I am finishing my PhD here in Mexico, in Ecosur. I've been working with bees and especially bumblebees since 2010, something like that. I started with taxonomy, then I moved a little bit to other topics like genetics, biogeography, and conservation. I don't like too much titles, but I am the regional coordinator from the Bumblebee Specialist Group from Mesoamerica, and I am also a red list taxonomy authority for the World Specialist Group of Bees. So yeah, that's a little bit of what I have been doing and what I am finishing or what I am part of. And now I'll let Philippe introduce himself.
Hi, I am Philippe Sagot. I'm French. And I'm working here in Ecosur as curator of the collection with Jorge Merida. I arrived here in, I say, about 10 years ago, or 12 years now. I met Remy and then I start working here with him. So I'm going from France to Mexico regularly, about 6 months. And we are here working with bees, with all the species of bees from Mesoamerica, principally from Mexico. But I start working particularly with bumblebees about 10 years ago, but the last year I have not been very active in that. So it's very good, this workshop, because I have to revise all what we have in collection. And so, well, that's all.
Okay, so, well, we're starting with this beautiful picture from a colleague of us that's right here, Jorge. He took this picture very early in the morning. These are males of Bombus waisi. So usually, like males get together in them so they can sleep together or stuff like that. So it's a very beautiful picture. And just, I know maybe a lot of you do know about bumblebees and their, like taxonomic classification, but hopefully for the people who doesn't know. So bumblebees are inside order Hymenoptera, which are shared with wasps, bees, and ants from the Apidae family, where there's also carpenter bees or cuckoo bees. Then they're within the subfamily Apinae, so there's stingless bees, which are very popular, common around here, honeybees, and orchard bees. The tribe is Bombini. And there's like a classification. It depends on who you ask. Some of them tell that bumblebees are semi-social bees. Others say that are primitive eusocial bees. I'm not gonna enter into that discussion, but basically that is because part of their cycle they are alone. So the queens start, after hibernating, they start to look for a place to sort their nest, and after a few months they start to have like a big nest with workers, and the queen only starts to just put eggs and the workers go and do all the other stuff. And we've been rearing bumblebees in here. So we do know that there are a couple of differences which we want to highlight right now. So that's why I put this one, temperate versus tropical bees. Probably you're familiar with the bumblebee from the Simpsons, but probably you're not that familiar with the other bee, which is the Mayan bee. It's a very common cartoon around here. So yeah, so just for you to know a little bit about that, there's a lot of differences between temperate and tropical bees and bumblebees. So while people around, like temperate places, North America, Europe, are more, they know a lot about bumblebees and their annual cycle. So they start this cycle with which I was explaining to you. In here, we do not have two things. One, bumblebees in here probably don't hibernate, so they become perennial. So we have sometimes a nest that can last for 2 years around, not just 1 year. Other times we do have that one of the daughters of the initial queen comes back to the nest and it restarts that, which doesn't happen over there. So yeah, that bumblebees. Another difference that's very interesting is that we do have lowland tropical bumblebees. So while usually bumblebees are temperate or mountainous, especially in Mesoamerica, we also have lowland tropical bumblebees. So you're in the middle of the jungle around, I don't know, 35 Celsius degrees, and you from time to time you can see a bumblebee, and you're like, what is a bumblebee doing here? So yeah, they have done some diversification in Mesoamerica and South America, and so we have a few species that are lowland tropical. A question that we still do not know for certain is if tropical bumblebees lost the diapause so they cannot hibernate, or is it facultative? So maybe in another place, another, like region, northern, probably, I don't know, Chihuahua or something like that, where it does kind of snow or you have glaze, they do the diapause, but we still don't know that yet. So we are still uncertain about that. And other things that we do believe that are different are temperature and humidity requirements, probably for all bumblebee species, but like lowland tropical species, they're probably very interesting, and we still don't have enough information. There's just a little bit of information for some species in South America, and it's kind of like backwards. So when rain starts, usually most of bumblebees do not start making colonies, but in South America, one species, that is the moment when they start to do colonies. So it's the other way around, right? So that's one of the many probably questions that we still do have, and activity time frame. While bumblebees over there, like in September or October, you can probably let me know better than what I know. They start to, like hibernate or look for places to hibernation. In here we have activity December, January. Right now we still have activity from bumblebees, so they never go to hibernation, right? So they are still also doing pollination all year round. Now, as a monophyletic group, we do know.
May I ask a question from the chat?
Yeah, for sure.
So Clay asks, which species begin foraging at the start of the rainy season? That's amazing.
Yeah, so well, in Mesoamerica, all of the species. So we have like, I don't know, like 23 or 30 species, probably all of them are doing that. But the example that I was giving you is Bombus transversalis, and it's a South American species. There's a little bit of information from it if you want to search for it. And it's very interesting to know that it's kind of like the other way around. So yeah. Any other question?
Thank you.
Yeah, no problem. So just like a general idea, also bumblebees, it's a monophyletic group. We have around 250, 60, or maybe 70 species, hopefully, when we publish them. The probable origin is Asia, right, in the Palearctic, and they probably moved to Europe and North America around 300 to 20 million years ago, and then they just keep going down, cross Mesoamerica and down to South America around 7 to 4 million years ago, based on Heather Hines' paper. And usually in Mesoamerica, they are mountainous insects, although I told you that there's a lot of lowland tropical species as well. Well, not that much, but there are like 3 or 4 species. But this paper, this is a new one from Williams and some collaborators, Remy as well in here, which analyze a little bit the dispersal of mountainous grassland and lowland grassland bumblebees. And what they find is a very interesting thing. So one of the hypotheses that Panama Isthmus closed around 7 million years ago, but what Williams' information and data set is kind of telling him is that it was like 3 million years ago, not 7. So what they are telling in this paper is probably that Mesoamerica is a place where there was a radiation of bumblebee fauna that later on moved down to South America. So this is a very interesting thing because the other like radiation places, you know, like the Palearctic, what we were talking right now. So we have a very diverse bumblebee fauna, although we have like, you know, like we're gonna see around 30 species, and you know, North America has like 45. But it's very interesting because we are very mountainous, very we have a lot of barriers. I'm gonna talk a little bit about that. So it's a very interesting place to study bumblebees as well. And when I am going to refer to Mesoamerica, I'm going to refer a little bit about Mexico and Central America. And these are records that we have for bumblebees from Mexico and Central America. We do have more. This is just a little glimpse. The blue ones are historical records, something before 2005. And the red ones are actual records, something until 2015, something like that. So we have a little bit more information nowadays. But this gives you a general idea of what do we have in Mesoamerica, where do they probably distribute. So you can see the mountainous areas that are very important for bumblebees. In Mexico, in Guatemala, the highlands is another place of very importance for bumblebees. And then there's El Salvador, Honduras, and Nicaragua are countries that haven't been well surveyed. So those are places that we still do not know yet what's the bee fauna and bumblebees as well. And Costa Rica, they have a lot of data until 2000. Then they have a few more data after 2012. And they are usually restricted to mountains, although lowland tropical species over there are very common, while in here are like in Mexico and Guatemala, they're a little bit like not that common. In Costa Rica, you can find species like in lowland, like at 70 or 60 meters above sea level, and they are in there. So they are more common like lowland species in Costa Rica. And this is like our thank you to Philippe. This is our like most actual general idea of what species we have in Mexico and Central America, Mesoamerica. So we're gonna basically the whole idea for this class 2 is to try to divide the species by subgenera. So we have Bombias, Bombus, Cetheras, Bombus, and Bombus as the subgenera that you are going to find here in Mexico and Central America. The most diverse is Bombus. Bombus is the second one with 8 species. Then Bombus with 7 species. So it's more common in North America, but in here it's more common Bombus. And then you have 1 species from Bombias subgenera and 1 from Cytheris, or the cuckoo bumblebee. Want to add something to them?
No, not yet. We can talk.
So what we have done in Mesoamerica with bumblebees, I am not going to talk about all the works. I'm just going to give you like a general idea of what we have done. We have worked a little bit with biogeography. Have a mistake in there. Taxonomy, which we're going to talk a little bit with Philippe. So there's a lot of things: morphometrics, phylogenetics, phylogeography, and ecological age modeling. With pollination, we have a lab where we are rearing Bombus epipeatus, a native bumblebee, which is taking a lot of importance in here because there's like companies in here which are rearing Bombus impatiens. So in Mexico and Central America, Bombus impatiens is the one that is being used for pollination greenhouse services, but we are trying to change that, right? Because Bombus impatiens is just native from East North America. And we have done red list assessments, and we have a paper on climate change. So I'm going to talk a little bit about what we have done, very general speaking, and then we're going to enter to the taxonomy class with Philippe. So when it comes to biogeography, this is not our work, but this I think is very important for you to know, because it's like general patterns of distribution of bumblebees in Mexico and Central America. So one of the general patterns that you're going to find is the North Mesoamerican pattern. Species that represent this is Bombus steindagneri, Brachycephalus, and diligence. And basically, these species are in the, what would it be, northeast side of and south part of Mexico and in the mountains. So this is like a general pattern from North Mesoamerica. Then we have like a red thing in there. It's like the Isthmus of Tehuantepec. That has a particular name. Well, anyway, it's a barrier. So it's a biogeographical barrier that is very important for a lot of different groups, not just bumblebees. But in this case, bumblebees apparently are really bad at trying to move around that barrier. So that's one very important barrier to you guys to know about. Then the other general pattern, it's the South Mesoamerica pattern. So it's Chiapas, where we are, all the way down to Guatemala, and Central America down to Costa Rica. Then in that pattern, we do have two biogeographical barriers. One is the Isthmus of Tehuantepec again. So a lot of species from here cannot go up to North Mexico. And the Panama Isthmus, right, which is the other one that doesn't allow bumblebees to go down further to South America, generally speaking, right? Because there's some species that do it, but it's because they are lonely. The third pattern, it's Mesoamerican ample distribution. So it's a few species that apparently are distributed in all of Mexico and Central America, although I think this pattern is going not to be, you should take it with caution, because we are now talking about that Ephipiatus is probably 4 species and not 1, as we once believed. But Medius and Mexicanus, they are lowland species, so that's why maybe they have an ample distribution, although we still don't know that for sure. But this is another of the general patterns for bumblebees. And the last one, it's Mexican mountainous. Basically, we have few species that are very, very restricted to highest parts of the mountains. So, for example, Bombus huntii, which some of you probably know over there, we probably have. It's not the same species, although they look very similar, because it's very restricted to the mountains in here. So we are talking about, I don't know, 2,700 meters above sea level, all the way up to 4,000 or 5,000. They do not move lower, so they have been isolated from the other populations over there with you guys. So that's one of the other patterns that we have here. And this is like the general pattern. If you want to check out that paper, it's a very interesting paper, and with all the patterns and all the barriers. And then with Michelle Duenes, which is a PhD right now giving classes. I don't remember but over there in the United States. But her PhD dissertation was about Bombus ephipiatus and their genetics and like all the patterns that we are talking about a little bit. So that's why I was talking to you about this species. Bombus ephipiatus was probably a complex of 4 species, while it was once believed it was just one species. And in all her work, you can see that there's a lot of barriers, and there's a lot of populations probably diverging. So bumblebees apparently are really bad at moving from mountain to other mountains here in Mesoamerica. That's why we are finding this diversification, this radiation. And well, genetics is telling us that at the same time. So, and why does that happen also, right? Like the biogeographical barriers are not letting a lot of the populations move from one place to another. So we are getting these isolations. And that's why we are finding probably 4 different species. So one of the species will be northern of the Isthmus of Tehuantepec. The other 2 species would be sympatric around Mesoamerica nuclear or nuclear Mesoamerica, which is Chiapas, Guatemala, Honduras. And the 4th species would be in Costa Rica. And if you see them, like the color patterns and everything, they do seem different. But as probably Philippe's going to tell us, and Paul Williams usually tell us, color is not usually the most reliable characteristic. But in here, it does work a little bit. Now, when we're talking a little bit about conservation, so I don't know if you guys are familiar with the IUCN red listing process, but basically you have like a criteria, and you can classify bee species or any other species into this classification. Basically, most of all species are not evaluated, but when you have a data set, then you can start this evaluation process. The first process is maybe you don't have enough data, so it becomes data deficient. But if you do have adequate data, then you can give them like this classification. If it depending on the criteria that you're using, it will let you know if they are least concern. So there's probably they don't have any problem right now, or if they are near threatened. So maybe one of the requisites that was needed for it to become in a threatened category is not it didn't get into that criteria, but other of those criteria that were used were met. So you cannot classify it as threatened, but near threatened. If you do have adequate data, and if you do have, if you do have adequate data, and if they fulfill the criteria that you were using, then you can get species in vulnerable, endangered, or critically endangered. So then there's the other two last one classification, extinct in the wild and extinct, but we haven't been using those in here in Mesoamerica, or I don't think there's any other bumblebee right now in those classifications. They're probably just critically endangered as the worst threatened category. And we base a lot our work on the work that Rich Hatfield and collaborators did with IUCN assessments for North American bumbles. So basically it was the idea to try to see if historical records and current records, there was like a mismatch. Probably the distribution was like shrinking or something like that, and you get other information to give an IUCN red list category. So we did the same thing with the Mesoamerican species. As you can see in the map, we have like the records. So the blue ones are the historical records and the red ones are the actual records. And when we have another, you can see there's some black circles in there. There's those are like sampling effort. So it's a raster of the sampling effort that we have done for bumblebees around the region. So there are probably other regions better surveyed, like the highlands of Guatemala or the highlands of Chiapas, and there are other regions not that well surveyed, but we still have been in there. So Trans-Mexican Volcanic Belt or the mountains in Oaxaca on Guerrero. And what did we find? So basically, we find that when we analyze all the species and we have overlapping species with United States and Canada, so of the 23 species that were analyzed, that we could analyze, 21 were evaluated, and 12 of those species are threatened. So if you take out into account all the bumblebee species from Canada, United States, and Mexico, 20% of all of those species are in a IUCN threatened category. So you can say like that's a lot of species, right? Like 1/3. And in Mexico, we have around, let me see, 7 species out of 12. So that's more than 50% of the bumblebee species in here, which are threatened. So that's quite a lot. And finally, a little bit of the work that we've done with bumblebees in here, it's also around ecological niche modeling and climate change. So we did this models for 3 different labs and for 2050 or 2070. And so I presented here used like the general maps for the different species. The red colors are places which bumblebees probably are going to lose distribution. The yellow ones are places where the distribution will be stable around 2050. And green places could be potential places where bumblebees could find still humidity and temperature variables that are like good for them. So as you can see, a lot of the bumblebee species do lose a lot of the distribution and they start to go up into the mountains, at least in Mesoamerica. And when you so we don't know too much about how bumblebees move around the landscape or how much do they disperse. So what we did, we just thought, okay, we're gonna let bumblebee that is in Chihuahua go all the way down to Costa Rica and the other way around to see what happens. And in the other map, so that's the left one and the right one, it's a map where we are not gonna let bumblebees move, just what we do know of that species and where it has been moving around millions of years. And what we found is that if we let bumblebees from Mesoamerica move all the way around Mexico and Central America, we do not gain too much species. So they are losing because we have been talking about that. So they are not good at moving too much. So they are not going to move to the north, and they're definitely just going to try to move to the south. But if we do have barriers that they do not let bumblebees go to the south, they're probably just going to stay where they can and move more and more into the mountains. And so that's what we were finding as well. So there's going to be an altitude change. So I don't know, for example, if Bombus medius, which is a lowland species, the mean is around 600 meters above sea level, where you can find it. In the future, you're going to find it around 1,200 meters above sea level all the way up. So that's a 600 meters change. Bumblebee species. So lowland species are going to try to move up, but where their distribution is only at the highest part of the mountains, they're probably going to lose all their distribution, right? Because there's there's no more mountain to go up. And this is a little bit of what we found, right? As you can see, a lot of red colors, right? So yeah, a lot of species in the worst scenarios are going to probably lose a lot of the distribution, while in the least bad scenarios, they're going to lose not that much, maybe 7% in the case of Bombus steinwagneri. In the worst scenarios, they're going to lose around 92%. So yeah, that's a lot of variability, but and it's also a big problem for bumblebees in here. We did just one more analysis trying to see how protected natural areas would be, how much do they cover the actual potential distribution and the future potential distribution of bumblebee species. And right now, the protected areas don't cover too much of the distribution, but in the future and in the worst case scenarios, a lot of the areas are going to cover a little bit more of the distribution, right? So maybe right now, protected natural areas are not that much into their distribution, but in the future they could be more important, right? So those are things that we need to be thinking around when we talk about conservation measurements. If you all want to know a little bit more about our paper, this is the paper, and you can just find it, or you can email me and I can send it to you. So that's basically my presentation. I don't know if there's any other questions, Claire, before we move to the taxonomy part.
There are no questions in the chat, so I'd say move along.
Okay, cool.
That was a great presentation. I personally really liked that conclusion of using the anticipatory modeling of where ranges are going to shift. I think that'll be really useful for the preservation of land.
Hopefully. Yeah, it's a little bit sad though that there's a lot of that we're going to lose a lot of the distribution, but well, you know, it is what it is, so we need to do what we need to do. So I
think a lot of us didn't know about those barriers, so that was really cool.
Yeah,
move on to
yeah. And so I also left, that's my email, and I also left the link from our group page. Well, it's in Spanish, but we have a lot of information around, you know, like different bees, or we have pictures. We have a lot of things in there if you want to check it out, that too. And when we publish things, we also upload it in there. So yeah.
I'm sorry, I'm going to interrupt you one more time. Sam wonders, since colonies can last longer, are they better at regulating parasites and disease?
Oh, wow. I have never heard that question, Sam, and I don't think I'm capable of answering that one. So, what we have found in the wild is that there are bumblebees colonies which are infested, and they're still like okay. But the smaller they are, it's more difficult for them to try to regulate all the parasites. The bigger they are, you see less parasites. So yeah, that's one of the things we have found. I don't know if they are better at that because of their cycle, but that's what I could answer, which is not that good, but that's what I could answer. Yeah. Okay.
Thanks so much.
Problem. So now we will start with Philippe.
Yes.
So
Sorry. So we're gonna work with the microscope, with a binocular. I don't know how you say in English microscope, binocular. I guess the people that are listening, they already know what is a bumblebees. But here in Mesoamerica, we have among the corbiculate bees, it means the bees with females with corbicula, I mean the metatibia enlarged and like a basket to collect pollen. There are some species that could be confused with the bombus, particularly and in the. If we can, let's have a look at just to show.
Yeah.
Yes. Okay. I can't see in my microscope
Just
at the same time.
remember
Or see.
No, you can't.
Okay.
You can see that, and then so Philippe is gonna see it before, and then we're gonna put it in the camera, the stereoscope camera.
Okay. Put the camera.
Okay.
Okay. So
Looks good. We can see it.
Great.
okay. So if you consider that bumblebees are bees with a lot of hair and in which normally you can't see the cuticle, the tegument on the thorax, neither on the abdomen. So this Eulaema singulata could be confused maybe with the bumblebees because it's corbiculate bees. The main difference, I would say, the tongue of Eulaema, like all the Euglossini bees, is very, very long, which never happened in bumblebees. And another character easy is that Eulaema has no malar area. I mean the area between the eye, the lower border of the eye, and the base of mandibula is very, very short. Some bumblebees have short malar area, but not as short. And well, there are other differences. Bumblebees have the pack a character not so easy to see is that on the hind wing they have no jugular lobes, but it's not good for Eulaema because Eulaema has no jugular lobes. But almost all the other bees that could be hairy here in Mesoamerica, like some centuries, some Tyloglossa, some Mesoxyles, they have jugular lobe, very easy to see. Normally, they don't have malar area. Desarrollado, ¿cómo se develop malar area. So it's quite easy to recognize bumblebee in the field. Of course, we have only, as you have seen, we have only one species of Cyteris, which has no corbicula on the hind tibia because it's parasitic species. So with Cyteris, yes, we could have more confusion possible, but not really. I don't see. I don't think there are so many options to confuse. There is no, this criteria is not so good to separate. All the bumblebees have the first submarginal cell that I can show you, but it happens also in other species. But the first cross marginal cell, I will take on the Wilmate because it's clear wing bees. Yes. Okay. The first submarginal cell is crossed by a small vein that goes down here. Other bees have this, but some not. So it can sometimes help, like with Deltoptila, for example, which is a genus from mountain in Mexico, which could look like a bumblebees when there is no yellow on the face. Some have yellow, but others not. Bumblebees never have as yellow part. So we start with the bumblebees. Here in Mesoamerica, we have. Can we go back to the list?
Yeah.
We have actually 30 potential species. In reality, we have 5 species which are not yet described, and 25 species described and that are present in Mesoamerica with certitude. So the easiest way for us, I believe the easiest way to determine bumblebees in Mesoamerica, due to the fact that we have only 5 subgenus and not so much species as you have in USA, I think the best way is to start to determine the subgenus of the bees that you have in hand when you catch a bumblebees. The easiest to begin is to determine the subgenus. So I propose to work on that. It's not so easy always, but normally not too difficult. So Psyterus, we can do it quickly. Psyterus, so we are talking about the female. Determination of male is much more difficult, and we use always the genitalia to separate the species of bumblebees. It's in general, it's much better, and you have no error. So with the female, and mostly with the queen, because also workers are not so easy sometimes, but in this case. So we start with Psyterus. In Mesoamerica, there is only one known species, which is present. The diagram that Oscar showed you from the publication of is a bit wrong, because variabilis does exist at on the north of the Isthmus of Tehuantepec. But it's very, very scarce. It's not common to encounter variabilis. In Chiapas, it's much more common, but still not so easy to encounter. I don't know if in Guatemala, but it's never very common. It's not so easy to encounter. So there is only one species, which is Bombus variabilis, or sometimes that you can encounter in publication as Bombus intrudens. So you have to look at the metatibia, which is not enlarged, which is not concave, is strongly convex, is full of hair, and in all other subgenus, this segment is wide, without hair on the disc, usually quite shiny and concave, more or less, and with a fringe of hair on each side, which form a corbicula. So with that, there is another particularity. I don't know if it's very easy to see. Let's have a look. Oh yes, here we can see, I think. 4 leg, yes. Okay. So we can go on. This is the apico, the terminology of to locate, para ubicarla.
To pinpoint the part.
Yes. is not always very easy to determine if it is anterior, posterior, superior, anterolateral, and all these terms are not always very easy to use and to be understood. Everybody is not using the same, but in this case, this is the apical part of the metatibia, and you can see here the internal part, which is with normal hair, quite dense. This is a particularity of Cytheris in the genus Bombus. All the other subgenera have what is called a rastellum that we will see. We can have a look now quickly. The rastellum is made of stout hair, which this one will give me the rastellum, I hope. Quite visible. Yes, okay.
While you're moving stuff around, we have a question from the chat. So I still hear the double, and I'm not sure how to address that. I'm sorry. So Mark is wondering if is it due to the multi-year colony cycle that only one Cyrus is present? I would have thought that the number of Bombus species present there would be more.
Okay, I'm seeing the question. Let's see. Is it due to... Ah, okay. Ah, wow. Another interesting question.
No idea.
Yeah, that's a really good question. Yeah, so no idea. We still don't know why there's only one cuckoo bumblebee species in the region. We still don't know why. That's a question we have not any answer at all. So I don't know. We don't know if that could be a hypothesis that Mark is actually asking. Maybe. I don't know how can we test that one, but yeah. So yeah, there's a lot of species that I'm gonna answer the other one from Sam related to the one with Mark. So Bombus cytherus, I have seen it parasiting Bombus ephipiatus, which is a pyrobombus. Bombus wilmate, which is another pyrobombus. That's what I have seen. Have you seen any other species that Cytheris paralyzed?
Then Ephipiatus?
Amphipiatus or wilmate? No. So those two pyrobombus, we have like knowledge and we have seen it in the field that they are parasitizing. But I don't know if there's any other
host.
Are those two sister species by chance? Just curious.
Yeah, but
Okay.
so well, before we thought that Ephipiatus and wilmate were different, were sister species. Now with after Duenes's work, it seems that wilmate is actually Ephipiatus, just another like color variation. But there is another sympatric species which is maybe gonna be called Bombus maya. We still don't know. It depends on when they finish the publication. But yeah, so it's basically the same species, just different color. But for the meantime, it's the sister species. Yeah. Okay.
So we lost one species.
Yeah, so we lost one species and we gained like
24.
3. Anyways, no, cool. Thanks to you guys. Really cool questions. Yeah. Difficult ones. I like that. Mm-hmm. So back to what Philippe was saying. So just to a little reminder, we were seeing a Cytheris, and it didn't have this structure that now Philippe is going to let us know.
What is called rastellum, which is common in many bees, but in Cytheris there is no, and in all other subgenera of Bombus there is a rastellum. But well, you don't really need just a detail, but with the shape of and the form of the metatibia, there is no doubt you're going to Cytheris. What is this? Brachycephalus. Then after there is one genus, mostly from North America. It's very rare in Mexico, which is the subgenus Bombias. We have very few records from Bombias nevadensis. I can show you quite easy to separate all the bombias from, yes, okay, camera pause for the wall. Yes, I can do it. Sorry.
No, no problem.
Okay. This is a right mandible, mandibula or mandibule? Mandible. In on the upper carina, the upper carina of the mandible in bombias stops. It is not fused with the apical part of the mandible, and this is a character, very easy. And then with this, you're sure you are not in Mesoamerica in presence of any of the other subgenus, either Bombus, Cypsiterus, or Thoracobombus, Bombus. No? Okay, so it's very easy. It's exceptional. We have all records. We've been to these places to try to find again this Bombus nevadensis, and we never could find it. We don't know if it extended or no idea, but it's really exceptional and quite far from its North American distribution. Then the following character is the most difficult sometimes, but sometimes very easy. You have to look at the mesotibia, the tibia median tibia, on the dorso-apical part. Okay. This will be a little difficult to see it. This is the dorsal part, this is the ventral part, this is the left mesotibia. And if you see this angle here, is very sharp and there is a spine. This example is very, very typical because in quite other thoraco it's not so easy to see, but the idea is to look at this this part, this mesotibia apicodorsal part, and with a pin you can go this way, and if it goes round, then you know that there is no angle. If it goes like this, well, sometimes the spine is not so sharp. It's just an angle, a sharp angle of 45 degrees or less. But so you decide that there is an angle, so you go directly to Thoracobombus, which is the most diverse in Mesoamerica. If there is no angle, then you have both options, Culumanobombus or Pyrobombus.
So you should be seeing here,
yes,
right?
Yes. It's difficult to see with the. Usually you move your beads around and you see it very well. And if you have a dart with a pin, it works quite well. Then once you have your Thoracobombus, we'll let him. If the apex is round, then you have two options, Culumanobombus or Pyrobombus. It's much easier. Culumanobombus, then the best way, I think the best way is to have a look at the front. Here is, okay. Okay. So we some literature use the virtual line that join the upper part of the compound eyes. Other use the virtual lines that join the shorter distance between the compound eyes. For the queen, the best for me, but for the species we have in Mesoamerica, if the virtual line that join the shortest distance between the compound eye cross the lateral ocellus, then you have a Bombus. If this virtual line is below, so I can show you another Pietus, for example. A bit of time. Okay.
Yep, I was just gonna say, we have a 5-minute warning.
Okay. Can we use a little bit more?
Can we?
We would love to have you back, but I don't think we're gonna get through everything today.
Okay.
And we should definitely have you back for a long series.
Okay.
This virtual line here cross the anterior ocellus, but is below the lateral one. No? And the other, moreover, is come from here. Okay. So the lateral ocellus is above. The criteria is that when triangular ocellar triangle, ocellar triangle, I would say yes. Ocellar triangle is over, one would say up the virtual line between that join the upper part of compound eyes. With all the queen we have from Bombus or Bombus, they always the ocellar triangle is always below. It works. This criterion works only with workers, with most of the workers. So there is a very, very big difference in this criteria between workers and queens. That's a problem. So to go to subgenera, you better do it with the queen and with the male, because genitalia is very characteristic. With the worker, you have to be very, very careful, because there are some worker, particularly in Rufocinctus, the Rufocinctus from Mexico, which is from very high elevation and quite rare. The worker are not so easy to determine as Bombus with this criterion. So sometimes it's a problem. So there is another very useful character. The distance, one of the relative diameter of the lateral ocellus with the distance between this lateral ocellus and the border of the compound eye. In Bombus, this distance will always be less than twice the diameter of the lateral ocellus. In Bombus, the distance between the lateral ocellus and the eyes is at least twice the diameter. In this case, for example, we can see that you can put 1, 2, a little bit more. So it is at least twice. This is the best character for us to separate the subgenera with workers. Okay, so there is another criteria with the antenna. I will show you this antenna between And we are talking about the 30 species or potential species we know from Mesoamerica. All these criteria probably don't work with all the bumblebees from North America.
Pregunta Claire si todos los tracobombos tienen espina.
No. Digamos que I would say yes, but some are very small and one does not bear spine. Is a Bombus digressus from Costa Rica.
Okay, so Claire, I just asked Philippe your question if all thoracobombus have a spine. He says that most of them do, but some of those spines are very small. And in the case of Bombus digressus from Costa Rica, it doesn't have a spine.
Mm-hmm.
Great to know. Thanks.
Okay.
Okay.
Entonces creo que solo con lo de la antena ya terminamos la clase.
Uh-huh.
So we're gonna finish with this antenna characteristic, I guess.
Okay. What if you want? Okay.
Thank you.
Come on. This character is valuable also for Pyrobombus and Thoraco. The queen, the first, this is the antenna. So this is the flagellomere. So the first flagellomere is shorter or as long, but normally it's always shorter than the second and the third together. No?
Mm-hmm.
If you look at all the species we have of Bombus, I will show you Bombus haueri, for example. I hope it works. It's a bit long. The example is not very good in that one, so I will take another one because haueri is just the same length, a little bit shorter. But where is brachycephalus? Well, I'm not convinced. We just keep this. It's two borderline. It's just the same length, but we're gonna forget this criterion.
That's pretty
No,
much
the Ocellus criteria and frontal distance is the best to separate the subgenera. And once you lead to the subgenera, we have a chance in Mexico and Mesoamerica that most of the species are very how we say mono pattern. How we say
monopattern.
Monopattern. So Bombus medius is always Bombus medius. We don't know any variation. Mexicanus is Mexicanus. Steinerschneri is Steinerschneri. There's no variation. YC is more difficult. That's why you have seen in the list that we have Negrodorsalis and YC, which are normally synonymous, but we are almost ready to publicate. They are really different species, and Trinominatus and Xelahuensis are quite stable geographically. And on the north of the Isthmus of Tehuantepec, Trinominatus has the same pattern, and on the south part, Chiapas and Guatemala, and Xelahuensis has another. So really, once you in subgenus, it's quite quite easy to determine some species. The problem in Mesoamerica is that we regularly find new species. So go to subgenus is the first step. Then you will for example, with the only work that exists really, which is La Bougle, the work from La Bougle. If you use this key, well, you will lead to a species, but it may be a new one that you have a look. So, for example, on the eastern mountain of Mexico, of the, how do you call La Sierra Oriental?
Sierra Oriental.
In La Sierra Oriental, we found recently a new species. Well, recently, 10 years ago, but it's still not publicated. Which is common here. It's from very high elevation, above 2,050 to 2,500, and this species has been mistaken with Bombus weissi. There is nothing to see with Bombus weissi. It's very, very close to Bombus trinominatus, but it's not. So, and there are other species like this, Nigrososalis and weissi, which are conspecific. Nigrososalis is from Chihuahua to Oaxaca, and weissi is from the center to Guatemala and
Costa Rica.
Hasta Costa Rica, yes. But they have a region in the center of Mexico which overlap, and you can meet both species together on the same flower. It's common in Mexico State or which state? Other state, and well, close to Mexico.
Hey,
Michoacán, we don't.
And the Trans-Mexican volcanic belt, yeah,
Yeah.
sure.
And the difference are quite subtle, but if you extract the genitalia, then the light, it's evident. There is nothing to see between Nigrososalis and weissi. They are really very, very, very different genitalia. So there is no doubt, and we have made, since we found that the genetical analysis, Oscar is working on that, and it's the same. They are completely separated.
Yeah.
You have nothing to present.
No,
Hey,
no,
friends.
for the next class,
Okay.
yeah, for sure.
Okay.
I just want to say thank you so much. We have a lot of thanks to you from the chat of addressing this new region for us. We would obviously really love to have you back. And you don't have to leave. You guys can keep chatting. I'm just interrupting because I need to end the recording.
Okay.
So if you all want to stay on, I'll leave the room open. And I'll be emailing you about when we can bring you back.
Sure.
Thank you.
This is Sam, and I'll follow up